Okay, so we have changing a decimal to a percent. We move it 2 spaces to the right and it becomes 7%. 2 spaces to the right, 16.5%. When it is like this, we have 2 options. We can either make our decimal into a 100, our fraction into a 100 like this, and then say, what would I do to make this 20 into a 100? 17 times 5 is 85 over 100, which is 85%. Or we can do denominator here, numerator here, and divide out. So it would be like this, and then we would do this. What is 30% of 20? We put the 20 here times 0.30, and then we divide out, or on the calculator, we just do 20 times 30%, or 20 times 0.30, either way, and it is 6. To do it as a decimal, we have tenths, hundredths, thousandths, 10,000ths right here. So this is a 1,000. It would end right here. So we put the 17, we put a 0, so that the number ends on whatever the denominator is. For this one, we would put into the calculator 3 divided by 20 equals 0.15, and to do it by hand, we would do denominator and numerator and divide that out. This is 5 to the 4th power, so we would do 5 times 5 times 5 times 5, or on your calculator, do 5 to the 4th power, 625. I wanted to do prime factorization tree as a review. When the number is prime, we circle it. And you can use any factors that you want that go into that number. So we have 1, 2, 3, 4, 2 to the 4th power times 3. Okay, for this one, we would just put it into the calculator. 3.2 times 0.05 equals 0.16. This one, we would do 20 divided by 0.05, 400. If we were doing it like this, we cannot have a decimal right here, so we move it over 2. We move it over 2 here, and then we divide it out into 4. We bring this, we bring that. Okay, I know we talked about this last time, but I just want to go over it again. Biggest integer wins the sign. If you have a negative and a negative, it makes you add these 2 integers together. This one, biggest integer wins the sign. We have a negative and a positive, so we subtract. This one, biggest integer wins the sign, so the answer is positive. We have a positive and a negative. It is 4. This one, we have 2 negatives together, so we make that into a positive. Negative 2 plus 7, biggest integer wins the sign. It's 7. Okay, a number y is 5 times greater than 2. Add it to a number. Write an expression for y in terms of x. If x is 3, what is y? So y is 5 times greater than 2 added to a number x. So y is 5 times greater, y. Then 2, add it to a number, and then you would solve for x, and that would determine what y is. For this one, they give you what y is. They give you what x is. You have to figure out what y is, so you would plug x in. So we just solve until we get to y equals the number. For this one, we would distribute the 3 out because it is touching the parentheses. So we would distribute 3 times 4y is 12y, and then minus 3 times 2 is 6. So it would be 12y minus 6. So they might give you y equals 2, and then you would plug that in. 24 minus 6 equals 18. We already did that one. Okay, so we are going to do mean, median, mode, and range. So for mean, we add all the numbers together and divide by the number of numbers that we have. So if we have 2, 3, 4, 4, 6, 7, 7, 7, 8, 9, 11, and 12, go ahead and work this through. Tell me what you get. You can pause the video, work that out. Okay, so when we add all of these together, it equals 83. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wait. Did I miss one? Oh, I missed one, so it wouldn't be 83. It would be 80. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divide it by 12. So on our calculator, we would do 80 divided by 12, and it equals 6.666666. So we would round that to 6.67. Now, these will not necessarily be in order, but to find the median, we would have to put them in order. So if they're not already in order, we put them in order, and then we cross out one side, one side, one side, one side, until we get to the middle. So this is a 7. Our median would be 7. This was our mean. If it turned out that these two were what was left, you would do 6 plus 7 divided by 2. So it would be 13 divided by 2. And then on our calculator, we would do 13 divided by 2. It would be 6.5. But for this one, it did land on the 7, so we are 100% fine with that. For the mode, that is the most frequently occurring number, so we're going to look at our numbers. 2 is definitely not it. 3 is not it. 4 has 2, so far that's the most. We have 6, we have 3 7s, so it is 7. The range is the largest number, 12, minus the smallest number, 2, and that tells you the range of numbers in both of them. So now we do I will give you another one to do, and you can figure that out. So here are your numbers for you to do. Okay, To find a percent of a number, write the percent as a fraction. So if it says 20% of 60 is 12, you are going to do 20 over 100. So if simplified that, it would be 1/5. Of means to multiply. 60 equals 12. And then we do 1/5 times 60 over 1. 60 divided by 5 is 12. 25% of 40 is what number? So for this one, we do 25 over 100, which equals 1/4, times 40 over 1 is what number? We do 40 over 4, which equals 10. 60% of 150 is what number? So for this one, we do the part of the whole, which is 60 over 100. And then we do 60 times 150, 100 over 1. And then we can do either this and it becomes 6/10 and we can multiply, or because we are now in high school, you can use a calculator. So it's 9,000 over 100, then you put in 9,000 divided by 100, and the answer is 90. So you can find the percentages of these ones: 90% of 20, 75% of 32, 10% of 110, 30% of 75. 175% of what number is 42? 85% of what number is 17? That should be good practice for you. Okay, our next one is going to be to solve this one. So the first thing we're going to do, they're adding 9, we subtract 9. Anything we do to one side, we do to the other. We're left with 3x. -9 plus 5 is -4. We divide this out to get the 3 away from the x. The answer is -4/3 or -1 1/3. If we have a fraction, we do the same exact thing, and to get my fraction away from my letter, I just use the reciprocal and the negative stays with it. So -3/4 m equals 5. Use the reciprocal. -4/3, -4/3. This cancels each other out. We're left with m, -20 over 3. We simplify it. It's as simple as it can go. For this one, we can have something where our first step is actually combining like terms like this. So we would first combine 1t and 3t and figure out what the negative sign and positive sign would be. Order of operations, we use PEMDAS. We did that in our last video. I'm going to send you something to work on for homework. And we are going to go over we did two-step equations, absolute value. Go. Associative parentheses change. Commutative order changes. And identity is anything equals itself. A times 1 equals A. Then distributive property, whatever is touching the parentheses here gets distributed into here like that. Okay, we have a sequence of numbers. We have to figure out how the number changes. So this could be minusing, it could be multiplying, it could be dividing. So we try to figure that out. So pause the video, try to figure out how that is changing. It's kind of a tricky one. And it is multiply by -1/2. This one is 2, 4, 16, 256. Pause the video and try to figure that out. It is, number is being squared. All right. We are going to do a quick geometry. This is a point. This is a line. It goes on for an infinite direction. A ray has one side that stops, one side that goes on. A line segment has a start and an end point. Collinear points are points that lie on the same line. Any 2 points are collinear, so if I put an A here and a B here, they are collinear because you could draw a line to connect the 2 points. Non-collinear points do not have the same line, so an example would be something that looked like this was A, this is B, and this is C. A plane is a 3-dimensional version of a line. It's like a wall that extends in all directions. If something intersects, it means it goes through, and it is a place where 2 lines meet. So that would be an intersection. If the 2 line segments are the same and they are of equal length, we call that congruent. This is an acute. It is less than 90 degrees. So this is acute. This is right. It forms an L and it has a 90-degree angle. It's also called a right angle. And then anything that is more than 90 degrees is obtuse. So it is named something like this. We could call it angle CAD, angle DAC. Okay, congruent angles are angles that have the same measure. So, for example, I didn't draw that exactly right, but suppose these were the exact same angles, we would be good to go. This would be congruent. Complementary angles are angles that, when put together, would equal a 90-degree angle. So that is a complementary. So I just saw that you didn't see any of that. So acute is less than, a right is 90 degree or right angle. Obtuse is more than 90. We show this as angle CAD or DAC. Vertical angles are, they have a common vertex, but their sides form lines and they are equal in measure. So we have 1 and 3, and we have 2 and 4. Angles 1 and 3 are vertical angles and they are equal in measure, and angle 2 and 4 are vertical angles and they are equal in measure. Transversal is a line that cuts through a pair of lines. So if you had something that looked like this and you drew a line through it, this would be angle 1, 3, 2, 4, 5, 6, 7, and 8. So when the lines are parallel, that is an important distinction. And then these are equivalent and these are equivalent. So this is line L, this is line M, and this is line N. So line L is a transversal through lines M and N. We have alternate interior angles, and those are the pair of angles that are opposite to one another. And they are the ones that cut between the two transverse lines. Alternate interior angles are equal in measure. So 3 and 6, 4 and 5. Alternate exterior angles are 1 and 8 and 2 and 7. Corresponding angles are pairs of angles on the same side of the transversal where one is an interior angle and one is an exterior angle. So 1 and 5 are corresponding. 2 and 6 are corresponding. 3 and 7 are corresponding, and 4 and 8, because they're basically at the same place on the different line. So alternate interior angles are 3 and 6, 4 and 5. They are the pair of angles that are on the opposite sides of the transversal and in between the two transverse lines. They are always equal in measure. So if we know what this one is, we will know what the other one is as well. The alternate exterior are 1 and 8. They're the opposite. They're at the exterior. 2 and 7, exterior. They are on the same side of the transversal, where one an interior angle and one is an exterior. That is the corresponding 1 and 5, 2 and 6, 3 and 7, 4 and 8. So that is pretty much, supplementary angles are a pair of angles that sum to 180 degrees, which is a straight line, and it would be something like this. So here's our first angle. We'll label that A, and our B angle is right here. And if you put them together, they would equal 180 degrees of a straight line. Adjacent angles are angles that share a vertex and a side. So angle A right here and angle B are adjacent angles. Linear pair is a pair of adjacent angles that form a straight line, and an angle bisector is a line in the interior. So we have something that looks like this. We have a line in the interior of the angle that contains the vertex and divides the angle into two equal angles. So this isn't exactly equal, but it is close. We are going to do probability of independent and dependent events happening. So events are independent when the outcome of one event does not influence the outcome of a second event. When the outcome of one event affects the outcome of a second event, the events are dependent. So independent, the outcome does not influence the outcome of a second. Dependent, the outcome of one event affects the outcome of a second event. So we talk in terms of probability here. To find the probability of two independent events both occurring, we multiply the probability of the first event by the probability of the second event. And we show that as P parentheses A and B equals P A, the probability of A, times PB, the probability of B. So the whole thing reads as the probability of A and B equals the probability of A times the probability of B. To find the probability of two dependent, so this was two independent, dependent events both occurring, multiply the probability of A and the probability of B after A occurs. So it is dependent on the other thing happening. So we do the probability of A and B equals the probability of A times the probability of B, and we write following A. So an example is the probability of tossing two number cubes and getting a 3 on each one. So the probability of 3 times the probability of 3. These events are independent. So this is cube 1 and cube 2. It doesn't matter if this is a 6. This has a 1 in 6 chance of being a number, and this has a 1 in 6 chance of being a number. Just because you get a 3 here or a 6 here does not influence this at all. So they are independent. They do not depend on one another. So we have 1/6 times 1/6, and the chances of getting that is 1 out of 36, and we could keep that as a fraction, or we can put it as a decimal, but because we're doing it this way, we can just keep it as a fraction. It means that you have a 0.027% chance, or a 0.03 rounded, I would rather have it be in a decimal because this makes sense to me. The 1 out of 36 isn't as clear. This is like almost a 0% chance, and so I like to make it into a decimal as well. A box contains a nickel, a penny, and a dime. Find the probability of choosing first a dime and then, without replacing the dime, choosing a penny. So these events are dependent. The first probability is 1/3. The probability of choosing a penny is 1/2, since there are now only 2 coins left. The probability of both is 1/3 times 1/2, or 1 out of 6. And then we can write that as 1 divided by 6. That is a 16.6 chance, or a 0.17 chance. So I am going to give you these ones to do. I will send these to Mom.